Today we will start median finding problem. In median finding problem, what happens? You have been given a set of numbers, an array, or you can say an array. So you have been given an array. This is the array. So this is the array. The numbers are a1, a2, a3, dot dot dot, like this. Clear? So this is the array, or you can say this is the array. Name is a. Better in this way. Okay. So this is the array, and you have to find out the median. So what do you mean by median? Means if the numbers are in sorted positions, then the middle element will be called the median. Clear? So we can say informally that we want to find out an index I for which there are exactly n by 2 elements or numbers larger than ai. So if there are even number of elements, then you know that there will be two median, and if there are odd number of elements in the array, then there will be one median. Now how can we find out the median? Okay, so first see what will be the very easy solution. Easy solution is that you simply pick up an element. Clear? It's the first element, and check whether it is a median or not. How can I do? I can compute how many elements are less than it, or say how many elements are larger than it. If I see that n by 2 numbers are there which are larger than that ai, then we will call that ai as the median. Otherwise not. Then I will select the next one. Now you see, if I select only a one element, then it needs big O or theta n time to check whether whether that element is median or not. It needs theta m. Why? Because I need to compare these element with the remaining elements of the array. Clear? And there are n minus 1 elements than in the other array. So therefore I need linear time to find out whether a particular element is median or not. Now it may not be. It may not be the median element, so I will check another element. So again another linear time. I will do again another checkup for the next element. In this way, I have to check up all the elements whether they are one of them is median or not. And if I do like that, then n into linear times means n square. So theta n square time. But this is not good. This is not efficient algorithm. So let us try for the better one. Is it clear? Why n square?
Yes, sir.
Next,
Yes.
you may sort the array. You may sort the numbers using say merge sort, suppose. Okay, comparison sort, So if I sort them using merge sort, then the middle element, since this is the array, I can access directly the middle element of the sorted array, and that will be the median. But you know that if I would like to sort the numbers, then it will take at least n log n time. So in merge sort, n log n I know. So the total time complexity will be n log n time. Now next question, is it possible to further improve? See, we have improved it from n square to theta n log n time. Clear? So is it possible to reduce it? Means, or in other way, can we find out the kth smallest element, kth smallest number from an array? Kth smallest number means, see, if 1th smallest means first element, smallest, why I am asking this, that if I have been given an array, this is the array, and in this case, if I know that I can find out the smallest element from an array, how much time it takes to find out the smallest element?
Linear time.
Linear time means first smallest element means 1th smallest element I can say, second smallest element also I can find out in linear time. Fine. So if I can find out the kth smallest element, this kth smallest element also in linear time, then I can say if I k equal to n by 2, then that will be the median. If the general problem kth smallest element can be find out in linear time, then I can find out the median also in linear time. So this is the challenge, whether it can be done or not. Okay, so this now we are going to describe the linear time median finding algorithm. Is possible actually, and it was designed by five famous persons. And out of these famous persons, means why I'm saying, you know probably that in computer science there are no Nobel Prize. Okay, so what is the highest award in computer science? Do you know the name of the prize?
Turing Prize, sir.
Yes, Turing. So Turing Award is we assume that this is the Nobel Prize in computer science. So among those, it was Blum, Rivest, Floyd. I think Floyd is also there. There are total five. Out of these five, four are the Turing Award recipient. Anyway, so they designed the linear time median finding algorithm. So what is the strategy that we are going to describe? So these are the few steps. Means it is just like it is similar to quick sort, but what happens in quick sort, we know that we select a pivot and we put it in the proper place, and then we recursively follow the two sublist, both the sublist left and right. Here we also do like that, but somehow we will not use the both the part, means left part and right part, as in the left part and right part, means once you divide an array into two parts, left and right, here we will use only one part, not the both. But in the quick sort, you know that once you pivot is placed at the proper positions, then two sub lists are created. Sub list means sub arrays are created, and we need to sort both the left and right. Here we will not do that. Now anyway, that is the that portion will be done later. But what is the first steps? The first step is that you need to group the array into n by 5 groups of size 5. So uh, this is the case. Say group the array A, I am writing array A into n by 5 groups of size 5 and find the median of each group. What does it mean? It means like this. Suppose I have say 2, 5, 6, 1, 13, 12, say 9, say -8, maybe 7, 44, in this way. So say 73, 26, like this. Okay. So if I have the numbers like this, then what we will do, I will partition these into group of 5. 1, 2, 3, 4, 5. Clear? 1, 2, 3, 4, 5. So in this way, I will go on partitioning the arrays into each group of size will be 5. Then what you have to do for all this, uh, you need to find out which is the median, of each group. Find the median of each group. So for example, in this case, if I sort it, then which one will be the median of the in this case 1, 2, 5. You check, this 5 will be the median. Here which one will be the median? 9, I think. Okay, like this. So you find out the median of each groups. Clear? The next, what we will do, recursively, you again apply recursion. Okay. So basically, what we are doing here, you can write that. Say, if you write this as a median, like this, from the array A, and suppose I am writing k. I want to find out the kth smallest element. Actually, this k is n by 2. Right? So I am calling this. So again, what I am doing, I am computing the median of each group, And suppose if you place all those medians in an array B, means B, array is B. So what is the B? B will contain say 5, this 5. This will contain 9, then next. And in this group say 20, 23, 23, 23 is the median. So here we will write 23. So I will get another sub array, an array. I will get another array whose name is B. Clear? That array consists of the median of each group. Then you recursively find the median of all these medians. So and I am calling the median of all these as the P. So if you want to find out the in the recursive way, then you tell me what will be the name of the function here. How do I call recursively? Median, you tell me.
So we say median A B.
No A, B, array B, na?
Yes, so sorry, B P.
No, here you see, I actually, okay, you, this is the kth smallest element. So in this case, what will be the okay, kth, or suppose I am just writing here, not k. I know the nth, suppose it is, this is a n array size is n, and here what will write means I would like, I want to find out the median of this, means half of the elements that is defined. Array consists of n. So here B, tell me what is the array size of B?
N by 5.
By 5, sir.
It will return this P. It will find the median of these medians, and I am calling this as the P. So it will return this recursively. Clear? Now we use this P as the pivot to split the subarrays into two portions. One of name is less, another name is the greater. Clear? And then I will recurse on the appropriate piece that I am explaining it how. So what happens? Suppose I have got this array B. Okay, so there are say for example say 41 like this. These are some arrays, element B. Now you are finding out the median of medians, median of this array, median of median. Now suppose here say 23 be the median of medians. So I will call this as the P. Fine. Now what I will do, I will place these P at the proper position of the array, entire array. Means I will array A is known. Okay. So I will compute what I will do. Now this is the array A, you know. This is the array A.
Sir, which method are we using to find out the median of the subarrays?
That is recursion. I am saying recursion. You can write a factorial of n minus. Then again you will actually see what you will do. Again you will subdivide this array B into means you partition these again into of size 5, 5, 5, 5 like this. And again you are finding this. And again you go on partitioning. So you will stop when? The question is stop when? If there is only one partition, suppose. One partition, then you can find out. Suppose only the array consists of 5 elements, then you can immediately find out which is the this median of this. Otherwise, what you will do, that I am explaining. Suppose you are writing the recursion, that I am saying that you are writing the recursion median of array n. Fine. Now you are calling, means you partition the array into n by 5 of size is this, and find the median of all those groups and put those medians into an array B, and again you call this from this. Okay, this means median, this function. here. Now what happens? Suppose you have obtained this P. Please remember, our objective is to find out the median of the array A. Clear? Now tell me, is P the median of the array A? No. P is the median of the array B. Clear? So it is not the median of the array A. We can say that this P is the approximate median, not exact median of the array A. P is the median of array B, fine. But P is the not the median of array A. Please remember. I will go through an example, then it will be more clear. So what happens here, that I have computed the median of each partitions, fine. Then I am computing which is the median of this array. So this was A. Please remember, this was the A, entire list. Clear? This is the array A. It's going on like this. And this is the P. P is the median of the array B. Now AP is the not the median of array A. Fine. Now what you will do? You place the P means 23 at the proper position. Means you will select this P as the pivot, and you will arrange the number of array A and A so that P is placed at the proper position. Means all these elements are less than equal to P, and all these elements here, see, I am partitioning the list into two parts. That I have described here. Use P as the pivot to split the subarray into less and greater. I am giving this name as as the name less, and this as the greater. Clear? So all these elements in this case is greater than P, and all these elements are less than P here. All the array elements. So what I am doing? I am placing this element at proper position. Clear? This is the pivot, proper positions. Now tell me, if it is at proper position, what means what happens? Our objective is to find out the, see, I have ordered all the elements of array A. After finding out the P, I will place the P at the proper position so that the all the elements before P are less than equal to P, and all the elements that occur after P are greater than P. That I can do. That you know the pivot in this method, you know this particular method, you know in quick sort. Clear? That how to place the pivot. Now next, what happens? Once you placed all these here, once you have done this, now you have here you see that this statement recurs on the appropriate piece. What do you mean by this? Our objective is to find out the median of the array A. Now if I can find out the position of P there, so I can write, suppose let the position of P in array A be I. Which position? After sorting, please remember, after sorting, sorry, not after sorting, sorry, after placement of pivot. After placement of pivot, so that the elements that precedes P are less than equal to P, and which elements are greater than will occur after it. Clear? Now if its index is I, now there are three cases. I may be, so there are three cases. Case 1, if I equal to 1, sorry, n by 2, then you tell me, if I equal to n by 2, which then is it pivot of the array A? Yes or no?
Yes, sir.
Yes, sir.
Its position is index is I. Yeah. So if I equal to n by 2, then it's so what should I write? Return P. case 2, that I is less than n by 2. If I is return n by 2, then what should I do? I should search where?
Greater part.
Greater part. I is,
So the lesser parts, actually.
yeah. Now just a minute. Say I is less than, yeah, lesser part. So what should I write? Then I will call which function? I will find out, call median as the name of the array. So here less or lesser, the name of the subject less. Suppose I am writing, either you can use less or you can use just like this. Better, I, you can use the call median a, and if you use the median a, then you need to give the uh, array size. Array size will be not the array. Just a minute, I'm changing it here. Then either you use, okay, median. You are, if you give, you are giving this, so uh, give the name, no problem, less. So lesser, if you give the name less, then it will be n. Clear? But if you use, means the array name a, then I think you should give the array size also. That array will be like this, not so only a, but you give the array 1 dot dot uh, I minus 1. If the array index starts from this, this. Is it clear? So if I use this this index, then means from 1 to a, 1 to I minus y. You see, this index is I minus 1. This index is 1. Clear? So up to 1 to I minus 1, I have to search this. If I write like this, otherwise you can use this just less. Now case 3. But please remember, if you use this format, then the previous format will also need to be changed. Case 3 is I is greater than n by 2. Then which portion it contains? If I is greater than n by 2,
If I is greater than n by 2, then the greater side, sir.
and less this will be I. Actually, that's, sorry, this will be I minus 1, na? Because the size of the less is I up to I minus 1, not n. Or you better, I'll say, na, use this method. Use this. You change the sequence the previous. This will be better. I am searching from array 1 to I, this. Okay. This. And here you tell me what happens. Call median. Which index?
A I plus 1 to n.
A I plus 1 to n. Yeah. And what is the size of this array? In this case, size of the array was I minus 1. In this case, size of the array is n
minus I.
n minus I. Is it correct? I am asking
Yes,
others.
sir.
See, how many elements are here? Total element is n. From these to these, n elements. Na? N elements are here. Here so in this case, this is the I. And okay, index starts from 1, then fine, it's okay. I thought 0. So anyway, then I need to search this. So you see, when I will get this, then I will stop, no recursion. Otherwise I will call, the size is reduced. And you check, is it possible that both these cases will occur at the same time? No, either these one or these one. So that means I will either search, I will either search from these portions, from the list or from the getter. Clear? So now, if you would like to find out the time complexity, how you can do? Means you have to, you see, in this way you you will get the median of these numbers. Now I need to call either the left or the right. Now I need the total time complexity. So first step, you tell me, you will get from the Coreman book, no problem. So in this case, you tell me what is the first step. Means let Tn be the running time complexity. Let Tn be the time complexity to find out the median. Median of array A. Fine. Now what you are doing? You are, first step, tell me, we are partitioning the array. This is the array. This is the array. Okay. This is the array. What you are doing? You are partitioning. How many partitions will be there? If each partition has size 5, tell me, how many partitions are there?
So 5.
5 partition.
N
Is
by
it?
N by
5
5.
N
partition.
by 5 partition.
N by
So n by 5 partition. Now tell me how much time it will take to create n by 5 partitions. This is the array. Means if I ask you to draw this blue color boundary, means partition means A5. Means the next, see, to find out the two partition means A1, A6, like this. Na? The starting of the boundary, na? The starting of the boundary is A1. Here A6. Here I can just this use this. Clear? So how much time it will take to create all the partitions? Tell me. Is it quadratic or linear?
Sir,
Linear.
linear,
For,
sir.
for see, if I ask you to create one partition, how much time? Constant time. Two partitions, 2 into constant time. So n by 5 partitions. So time will be, so this time will be n by 5 into some constant C1.
Yes, sir.
Clear? Now what you are doing after that? Next step, tell me. I will not show you the figure. Tell me what we are doing. We are doing finding out the median of each group.
Yes, sir.
So to find out the median of each group, say I can use median of each group. So I can use insertion sort to find out this. You know, na, all this sorting. Why I am doing this? Because very simple. As only constant number of term each group. How many five numbers are there? So at most, how many comparisons do we need? Tell me. At most, in one partition, you tell me how many. If there are 5 elements, then how many comparisons are required to find out the median of those 5 elements? At most?
3, sir.
At most 5 into 5?
Oh, sir.
Yes, sir, 20.
At most 25 comparisons? To find median of one partition. One partition. Yeah?
Hello, sir.
Yeah? Hello?
Hello, sir.
Yes, tell me.
Sir, one confusion regarding partitioning, sir.
Which step? This step? This one? Or this one?
Sir, in one partition, we need constant time. In two partition, we also need constant time.
2 into constant time.
Sir, when we are doing n by 5 partition, we'll take the time n by 5 into C1. That step, sir.
See, I can find out one partition in constant time, C1 time. Is it clear? I am assuming that it needs constant time because I can access directly this element, A6. This is the array. This is not the linked list that I have
Yes,
to
sir. Yes, yeah.
C1. So similarly, another 2C1, 3C1. So for n by 5 partition, n by 5 into C1 time. Clear? For each partition, n by 5, sorry, for each partition, one C1 time. For n by 5 partition, so n by 5 into C1. This much time I need. Now, the median of each group, I can use the insertion sort. I know insertion sort means I have to apply the sorting. I need to sort all this. For example, here you see, yeah, 2, 5, 6, 1, 3. So what happens in this case? I will get, if I sort this, I will get 1, then 2, then 5, then 6, then 13. Okay. If I apply insertion sort to sort these 5 elements, I will need only 25 at most 25 comparison, not more than that. So next, so total partition is n by 5. Clear? So therefore, these steps needs how much? N by 5 into 25 comparisons total. That means 25 comparisons into these many comparisons. So how many? So that is 5n comparisons. So now, if I need to compare two elements, I need some time, constant time. Which one is larger, this one or this one? So all these steps needs how much time? These steps 5n comparisons into a constant time C2. And I have to multiply because one comparisons need constant time C2. So 5n comparison is 5n into C2. This much time I need. Now tell me what I am doing after this. Tell me after this, I am computing what? The median.
Median subgroup, sir.
Yes, recursively find out the median of these groups, medians. So how much time it will take? Median of median. See, I know that to find out the median of n element, it needs how much time? Tn. Here I have written. You check it. Time complexity to find out the median of n element is Tn. So time. So what will be the time complexity to find out the median of median? T of how much? How many elements? How many elements are there? N by
n by 5.
N by 5, sir.
this. I don't know what is this T of n. So, but I know since I am using recursion, so it will take Tn by 5. Yeah. Actually, why I am doing this? I need to add all these Tn equal to this that n by 5 into C1, then plus 5n into C2 plus Tn by 5. Clear? Now, anyway, the last step. Okay, not last step. Then I am using the pivot to split the array into two parts. So how much time does it take to split the array? Split array using pivot. How much time it takes? You know? How much time it takes to place the pivot at proper position?
Sorry.
Linear time.
Minute.
After that, what I am doing? See, I equal to n by 2, I less than n by 2, I greater than n by 2. Is it okay? So that means there are three cases. Whether the P means in which section means what is the index of this P. Depending on that, there are three cases. Now tell me, is it possible that all the three cases will occur simultaneously? Is it so? No?
No, sir.
So one of them will occur. Either case 1, that is the best case that I am getting, I equal to n by 2, I don't need to recurse anymore. Clear? And this takes constant time. Return P. Otherwise, I have to recurse the left side or right side. You see? I will recurse this side, this array, this left, or this right. But tell me, do you know which side needs to be recursed? I don't know. Either this or this. Is it clear? I have to recurse this or this. What is the size of this element? Do you know? In this case, I am asking. I have to see, please check. I have to recurse either less array or greater array. That means which case should I take? In worst case, thus I should consider that I have to recurse on the larger size. I have two people. So I don't know which one is the larger size. So this is the tricks you see now. What they told also here. Say, suppose I am writing all the elements like this. This is one group. I'm just writing the numbers. I am giving name like this. Sorry, this is 5, 1, 5, A, 2, 5. You can use a comma also if you need. Okay. If you in this way, you tell me what will be the last index. Clear? A11. In this way, I have written all these group, these partitions. These are the partitions. Clear? In my 5 partitions. Now, suppose I have given the numbers, means I have, and this is after sorting. Sorting means insertion sort that I told. So that means this number is larger than this is larger than this is larger than this. Okay. So these element A31 is greater than A32 like this. This is larger than this. Now, so if it is so, tell me which one will be the median of this in this case? First group here. Which element is the median?
A13.
A13. Fine. Then A23, A33. So these so this is the array B. Is it clear? Now suppose you have, means you can rename these elements so that anyway, means, or you can swap the columns, partition groups. Okay, no problem. So that means they are like this. This element is this greater than this in this way, less than this. And this is the median. Suppose say this element is the median of this. So that means this is P. Clear? Now there are so many numbers. I have not written like this here also. The numbers are like this, means say these in this way it has been there. So here you see A15 is less than A14, A14 is less than A13, A13 is less than A23, A23 is less than A33, and A33 is suppose less than obviously means P. So what is the relation between A15 and P? A15 is less than
P.
P. A25 is less than P. So you check all these elements. All these elements means here these blocks. Please check it. It's very interesting that these elements, all these elements are less than P. This portion. This block, I am saying again that this block is less than P. And you also see this block are greater than P, because this element is greater than this is greater than this is greater than this. In this way, this is greater than pi. So this block of elements are greater than P. So these are is it clear? Now can you find out any relation between A11 and P?
No, sir.
No reason. We can't say anything. But we are sure that this element means this is less than P and this is greater than P. Well, what is the size of this portion, this block, which are less than P, if total number of element is n? Tell me. N by 4. That's the 4 block. You check it. Is it not? Is it in this case? You see here, I'm saying, is it not that n size is n by 4? Here also size is n by 4. 4 blocks. Just like this, na? This is an element P. Okay, and this is the block. You see, if I partition like this, so n by 4, n by 4, n by 4, and n by 4. And I know here that these many elements are less than this, and these many elements are greater than P. So size of P. So you tell me now from this figure. So how many elements are less than P at least? So size. What will be the size of less?
N by 4.
LE double S is greater than equal to n by 4. Why greater than equal to I am saying? Can you say me? Because you see in this figure, do you know whether A21, this A21 is less than P or not? Do you know? A21 is less than P or not? We don't know. A21, there are no relation between A21 and P. So it may happen that A21 is less than P. So if it is so, then the size of the elements which are less than P will be more than n by 4. So, but I know that size of the elements which are less than P will be at least n by 4. That's why I am writing this is greater than equal to n by 4. Less. Similarly, greater, this size will be, you tell me, this size will be what? At least n by 4. So you see that this is the, again I am writing because here this is P, this is the array less, this is the array sub array greater. Okay, now less is greater than equal to n by 4. Greater, size of the greater, then tell me what can be the maximum size of less this array? Can you tell me? It will be less than equal to how much?
N by 2.
Why? See, greater is greater, that size of the greater portion is at least n by 4. So if it is greater is at least n by 4, at least, so then less will be maximum when? Tell me, the less, the size of the less will be maximum when greater is n by 4. Am I correct or not? Check it. Tell me.
Yes, sir.
Similarly, what can be the maximum size of greater array? This array?
3n by 4.
3n by 4. Say in the same way. Means when less is n by 4. So now you see what I told, that we have to recurse either less or greater, not the both. And I have to take care of the case. That means I should take the worst case. So what is the worst case size of the array that I have to? 3n by 4, not more than that. I know the size maximum. So how much time it will take to find out the median from that array in the last routine? In the last routine means here you are again finding out the median from this. So if it is so, that will take how much? T of
3n by 4.
Right. Thank you. T of 3n by 4. So let us write the entire equation. Few minutes are left. Just a minute. I should complete it. So Tn will be, again come here. Yeah, Tn is the time complexity first. n by 5 partition, so n by 5 into C1. Then median of medians, median of each group, it takes 5 in C2. So n by 5 C1 plus 5 in C2 then median of median Tn by 5 then T of 3n by 4. So here you see I can write this you see this is a constant, you check. Similarly this is also a constant. So by adding these two I can write that Tn is how much? T of n by 5 plus T of 3n by 4 plus some constant C3n, where C3 is C1 by 5 plus 5C2. Clear? Now, what will be the running time complexity? How much time does it take? Means if you solve this recurrence,
Sir.
Yeah.
Sir, actually our OOP class has started already, sir.
oh, at 4 p.m.
Yes, sir.
Just 2 minutes,
Yes.
only one.
Yes, sir. Yes, sir. Yes, sir. Okay, sir.
Just 2 minutes, within 2 minutes, I'm just saying. So, I'm not asking any questions. You assume Tn is linear. We assume Tn is some less than C into n, some constant. So if it is so, by induction we can write Tn, put it here. This will be less than equal to C into n by 5 plus C into 3n by 4 plus C3 into n. Now Tn is already, so that is equal to what? 20, 19. And Tn is, I know, Cn less than equal to. So means if I write it here, this portion, so this portion should be less than equal to, here put it here, Cn. If so here this will be true if Cn or C3n is less than equal to 1 upon 20 Cn or C3 20 C3 less than equal to C. I can choose this so that C is this, means clear, 20 C. So it will be linear. And just one important point, you please remember, I am telling you the tricks, that T of this plus this, if you add this one and this one and it is less than n, see n by 5 plus 3n by 4, it is 19 by 20 n. So this 19 by 20 is less than 1. So these will be the linear. Okay, I will discuss this more about later if you need. So today I stop it. Okay, thank you. Leave it.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.